Dersimiz gelsin tamam. Hadi oturttuk. I'm teaching now. Amir, are you there?
Yeah, hello.
I cannot see your face. Can you close the door? Amir, let's continue if you are ready.
Yeah.
Good. And now, in the previous session, we have just reviewed very quickly what is a quadratic expression, what is a quadratic equation, and how to solve quadratic equations by factorization. And the last method that we practice is about solving quadratic equation by completing the square. Okay, that is completing the square method. And also sometimes in GCA, they may ask you to solve the quadratic equation by completing the square method. So you have to follow those steps and you need to show all your work and get the solution, okay? Because when you're solving equation in very different ways, we can solve this. For example, in quadratic equation, in how many different ways can we solve this? By factorization, or by completing the square method, or by using the formula, or graphical methods. Graphical method means we need to draw this graph. We know that the graph of a quadratic function is, or equation is, or function. It is a parabola, right? Then we need to find it is x-intercepts. So x-intercepts give us the solution of the quadratic equation, okay? But that thing is, we will see maybe later, but now we will focus on number one, the third method. How do we solve a quadratic equation by using a formula? So now we are going to generate a formula using the same, actually exactly the same idea like completing the square method, okay? So what we are going to do here is, actually we are given quadratic equation. That is our quadratic equation. A, B, C are constants, they are given, and also we have one condition here, A must be non-zero number. Why is it so? Because if A equals 0, 0 times x squared equals 0, it becomes a linear equation. And we know everything about linear equation. At least we know. Now we want to just expand our knowledge, right? And that's why we are adding one more term. Now, if you add one more term here, that will be ax cubed. It will be more complicated. Ax to the power 4, it will be more and more complicated. Okay? So now, step by step. But now we are going to talk about the solutions of a quadratic equation. When we make quadratic equation, we mean this ax squared plus bx plus c equals 0. And that form, we call this a standard form of a quadratic equation. All right, that is a standard form. First, to solve the quadratic equation, we have to bring into this form and use this formula and get the answer. Okay. Now the question is, how do we get this formula? We will work on this. Now, using the similar idea here, this is our quadratic equation. Ax squared plus bx plus c is equal to 0. And a, b, c are real numbers, we know that, and a is not equal to 0. The question is, make x the subject of this formula. And make x the subject of this formula means, how can I isolate this x? How can I leave this x alone on the left-hand side? And on the right-hand side, we have an expression that involves only a, b, and c. It does not involve any x. That is a big question, actually. Who did this in 7th century, 8th century? Actually, that is Al-Khwarizmi. Maybe if you heard here, that is from Uzbekistan, from Khwarizm. He is the one actually who founded this idea. Okay, who solved this equation? Anyway, so the first thing is, as you know, when we are completing this thing to a perfect square, we need to have here x squared, right? So I need to eliminate this a. How can I do that? So let me divide both sides by a. So if you divide both sides by a, first I have here x squared plus b over a x plus c over a equals 0 over a, that's equal to 0. 0 is divided by any non-zero number that is equal to 0. Now here I have x squared. Good. Now I need to have 2 here because I have 2 in the formula, right? So I'll do another algebraic manipulation here. X squared plus 2 times b over 2a. 2 to cancel each other, so I have b over a here. X plus, what do I need here now? I need the square of this thing, right? To be a perfect square. So again, I will do another algebraic manipulation here. Let me just add b over 2a squared. All right. Minus b over 2a squared. And still I have here c over a plus c over a. On the right hand side we have 0, right? Now if you observe here the first 3 terms, what is it? It gives us perfect square, something squared, right? X squared plus 2 times this times x plus this squared over this plus gone. Here we have plus. So now I can write it as x plus b over 2a, b over 2a squared, right? And the rest are just numbers, right? Take them to the right hand side. What we have here, b squared over, where is it coming from? Okay, everything is correct. B squared over 4a squared, right? It becomes plus. And here we have, takes to the right hand side, becomes minus. If we bring it the common denominator, I should multiply this by 4a. 4a times c, here we have 4ac over 4a squared. Okay, now once again, if I just write this, because here we have a common denominator, I can rewrite this as in a more simpler way. Here we have squared. On the right hand side, draw a single fraction line. Here we have 4a squared, b squared minus 4ac, right? So on the left hand side, we have something squared. On the right hand side, denominator, also we have 2 squared, a squared, no problem. But here, about the sign of this number, I am not sure. That's why this thing is really important. That's why we are going to attach a special name to this expression. And we call this discriminant of the quadratic equation. And usually we use delta to label this. That is equal to b squared minus 4ac. Because this number, when you square b and multiply 4 by a and c and subtract this thing from b squared, it will be a negative number or positive number or 0, we don't know. And that's why we have to consider these cases separately. So number 1, the first case. And let's say this discriminant is greater than 0. What happens here? Then here we have x plus b over 2a, right? Squared will be equal to, here we have discriminant over 4a squared. Now it is positive. Something squared is always positive. It makes sense. So now I can find x here then. This x plus b over 2a should be equal to plus minus square root of delta over 2a squared. Now if I take to the right hand side, then we will get the roots of the quadratic equation. Here we have no square because square root of 4a squared is 2a. So here we have b plus minus square root of delta over 2a. That is the solutions, 2 solutions of the quadratic equation. So here we have x1 and we have another solution x2, and these solutions are distinct. They are not equal to each other and they are real. They are not equal to each other because here subtracting something or adding something to b, that give us different results, right? So that means that before solving the question, first you need to evaluate this. If it is positive, we continue. So from here now, we are sure that it has 2 distinct real solutions, okay? And how about the second case? How about if delta equals 0? If delta equals 0, what happens here? If delta equals 0, 0 over 4a squared is equal to 0, then we will have this equation, x plus b over 2a squared is equal to 0. So what number square is 0? Only 0 squared is equal to 0. So this thing should be equal to 0. That means that x equals negative or minus b over 2a. So in this case, how many solutions does this equation have? Still we have 2, because here we have square. But we say that 2 equal roots. Or sometimes we say that 2 coincident roots. Okay, because here we have 2 real roots and they are equal to each other. Okay, because of the square. All right, because I can write it as x plus b over 2a times x plus b over 2a. The first root is minus b over 2a, and the second root is b over 2a. And we call this repeated roots or coincident roots or equal real roots. They all mean the same thing. And how about the third case? Now, how about when it is positive, when it is equal to 0, and how about if this thing is less than 0? How about if discriminant is negative? As you see here, if negative, here we have negative number, it is positive number, negative over positive, it is negative, right? On the right hand side, something squared, it is always non-negative. So non-negative number cannot be equal to positive number. I mean, positive number cannot be equal to negative number. So we just write here, this equation or the given equation has no real roots. Okay?
Mm-hmm.
Very good. That's all about quadratic equation. If you understand this idea, now we can solve any kind of quadratic equation now. So solve. Now here we are going to use a formula, giving you answer correct the 3 significant figures. Now you know what we mean by significant figures, so I'm just going to leave this part, okay? So here the first step is we need to find discriminant. It is already in standard form, 3 squared here, minus 4 times negative 2, which is equal to 9 plus, right, 1632, which is equal to 41. So here we have the first root, negative b, that is minus 3 plus square root of 41 over 2 times a. 2 times a, it is 8. Since it is third form, the second root always appears is conjugate. We call it as conjugate. So it is minus 3 minus square root of 41 over 8. Now using your calculator, you can calculate this and leave your answer correct to 3 significant figures. Another one, question A, 9x squared minus 42x plus 49. First, make sure that it is in standard form. On the right-hand side, we have 0. Okay, no problem. So immediately we can use the formula. First, we need to find discriminant, right? So since we have squared, always we have square here, so I can ignore its sign. 42 squared minus 4 times 9 times 49, which is equal to, using our calculator, 42 squared minus 36 times 49. That's equal to 0. I don't have to write this. So that's equal to 0. So what do we have here then? Then x1 and 2 is equal to minus b, that is 42, because plus minus discriminant is equal to 0, over what we have here, 2 times a. That is 2 times 9. So that's equal to 21 over 9, that is 7 over 3. So this equation has 2 actual repeated roots, they are 7 over 3. Okay, or coincident roots, that is 7 over 3. And how about B? In a similar way, just use the formula here. We have discriminant square, right? Minus 4 times 5 times 13. That's equal to 100 minus 20. 20 times 13. 2 times 13 is 26. 260, which is equal to negative 160. That is less than 0. So if this is negative, we know that it has no real roots. Okay?
Mm-hmm.
Good. So now we will talk about equations that are reducible to a quadratic equation. When you look at the question, a lot of equations, they may not look like a quadratic equation. Okay, now here we are going to see very simple one. Because these quadratic equations are really important. When you are solving trigonometric equations, you will see that we will need quadratic equation. When you go to university, when you are solving differential equation, for example, we need to know about quadratic equation. When you are studying business, for example, when you talk about the price and supply stuff, okay, supply and demand, all there also quadratic equation is used. I mean, the quadratic equation has a lot of application. That's why in every book there is a concept or a chapter about quadratic equation. Now here we are going to see a very simple one, okay? So we are given some kind of algebraic equations, okay, or equations that involve algebraic fractions. When we just do some algebraic manipulation or simplify this, it becomes quadratic equation. And such equations are called equations reducible to a quadratic equation. One example is this. If you look at this example, 6 over x squared, right, plus 13 over x over 8. And we know that this thing 6 over x squared plus 13 over x, right? We can write it as 6 times 1 over x squared and plus 13 times 1 over x, that is equal to 8. Now, if I use another variable, in math we call this auxiliary. All right. Auxiliary variable. That means that helping variable. So if I use, for example, let's say here it is y. All right, let's say y equals 1 over x. Okay. It's just helping us. This y is helping us to solve this equation in a simpler, easier way. Let's substitute here what I have here. 6 times y squared plus 13 times y is equal to 8. And take 8 to the left-hand side, it becomes a quadratic equation, something like this, right? Now we know how to solve this because already we got a tool, that is our formula. Using that formula or by factorization method, any method you like, solve it and we can get y. After we get y, again substitute here, right? And I can get the value of x. What is x here? X equals 1 over y. And substitute your answer here, right? You will get x. Okay, that is one method to solve equations reducible to quadratic equation. So the previous one, we have already done this. If you finish this, what we have here? That y is equal to 1 over x. That is our auxiliary variable. And substitute here, I have here 6y squared plus 13y. And take to the left-hand side, minus 8 is equal to 0. Okay. I don't know by factorization we can solve it or not. Or immediately, let me just use the formula here. 13 squared minus here we have 4 times 6 times negative 8, which is equal to 13 squared, right? It is plus 24 times 8, that's equal to 361. And we know that 361 is 19 squares, right? So from here, y sub 1, that's the first root, equals negative 13 minus b plus square root of delta. Square root of delta is 19 over 2 times a, that is 12, which is equal to, it is 6 over 12, 1 over 2. Now the second root is negative 13 minus 19 over 12, which is equal to, it is 32, right? And 32 is divided by 12 and divided by 4, it is 8, divided by 4, it is 3. So this thing is equal to 1 over x1. This thing is equal to 1 over x2. Now we can write our final answer here, dot, dot, dot. The first root of the equation is, if 1 over 2 equals 1 over x1, that's equal to 2. And second root of the equation is 8 over 3 equals 1 over x2. If you just flip them over, right, we will get x2, that's equal to minus 3 over 8. So we have two solutions. These are the solutions of the given equation, which is reducible to a quadratic equation. Okay. In similar way, how about this one? When you look at this, I can't say that it's a quadratic equation or not. But here I'm hoping that by simplifying this, it becomes a quadratic equation. And you know, I think how to solve this kind of equation. On the left, we have one fraction. On the right-hand side, we have one fraction. How do you solve this kind of equations? What should I do in the first step here to solve this equation?
Make it equal to 0.
We need to cross multiply, right? In math, we call this cross multiply. That is 3 times x minus 5. 3 goes here, equals 2x goes here. That is 2x times x minus 4. Cross multiplication. And now just expand this and take everything to the left-hand side, write in standard form, then we can solve this. So that's here 3x minus 15 equals 2x squared minus 8x. Or take everything to the right-hand side, 2x squared, negative 8x minus 3x, that is minus 11x. Negative 15 take to the right-hand side, it is positive, it is plus 15, that's equal to 0. Now we have converted the given equation, right, into a quadratic equation. Actually, these equations, are they same? Yes or no?
Yeah.
Actually, in math, we call these equations equivalent equations. Equivalent means they have the same solutions. They are not the same equations. You see, they are different. It's also different. But they are equivalent because they have the same solutions. Okay? So, using the formula here, delta, here we have 11 squared minus 4 times 2 times 15, which is equal to 100. Actually, let me just evaluate this. 121 minus 8 times 15 is 120. Oh, that's equal to 1. Good. That's equal to 1. So here, x1 equals minus b, right? That's 11 plus 1 over 2 times 8. That is 4, which is equal to 3. And second root of the given equation is 11 minus 1 over 4. That is 10 over 4. If you just reduce the given fraction into its lowest terms, that is 5 over 2. Dots, dots, dots. The solutions of the given equation is 5 over 2 and 3. So it has two solutions. Okay.
Yeah.
That's the last slide. Success is neither magical nor mysterious. Success is a natural consequence of consistently applying basic fundamentals. All right, Amir, now I will close this, okay? I will open another slide. We have 10 more minutes left. Let's solve one or two questions. At least I will introduce you to word problems and finish the class, okay? Let me open new one, stop sharing, and so Amira, the last part of this chapter is problems involving quadratic equations. And I hope before I forget, let me tell you, now I will give you assignments. It's all about this chapter 1, or I think it is not chapter 6, it should be 1. Okay, that is the last part of this chapter. So this chapter, I don't know how good you are. All right, you just solve the problems. Let me see. I mean, can you solve all the problems without having any difficulty? I mean, if you are having some difficulty, then you need to read maybe 2 or 3 times to understand the problem, or it's taking more time, then we will focus on this part of the chapter. Because as you know, as you see, this equation type problems, it's not so difficult because we're just following fixed rules. If you know the formula and if you know the procedure, we can solve them because they are all fixed rules. But these word problems, number one, you should understand the problem. That's a big challenge. Number two, you have to interpret or convert this into mathematical problem, or mathematically you have to describe it. That is another big challenge that most students actually have difficulties in solving these kind of problems. Then you have to solve it, and after you solve this, you need to pick the most suitable answer that actually satisfy your problem. Okay, so we have to go through like 4 or 5 steps. That's why a lot of students, they have difficulty in solving problems. But if you're really comfortable with solving these kind of problems, that means that you have really good problem solving skill. Okay, and hopefully you have a good problem solving skill. But still, this 1.4, Amira, when you're solving these problems, don't skip any question, try to solve every question. Okay, the previous exercises like exercise 1A, 1B, 1C, or maybe 1D even. Okay, you can do one question and skip one. You can do one question, skip one. You can do actually 50% of the questions. But I suggest you this kind of problem, that problems involving quadratic equations, that's the last part of the chapter. Try to solve every question. Okay, so we can use the techniques of solving quadratic equations to solve many practical problems. So we will see some of them. That is from geometry and from math and maybe from physics. Okay, so let's start with very simple question. Example. It says that the product of 2 consecutive positive odd numbers is 195. Find the numbers. So the product, you know what we mean by this, and 2, okay, we are talking about 2 numbers, consecutive positive odd numbers. So positive odd numbers, what are these numbers? Actually, we're talking about this 1, 3, 5, 7, ... These are odd numbers, right? And when we just say consecutive, we are talking about the numbers that are followed by another one. So like, for example, let's say just write a few numbers. Now here, this number, I don't know, because we just keep writing these numbers. I have some odd number here. Let's say it is n. If this is n, what will be the next number? N plus 2. Are you there?
Mm-hmm.
Because as you see here,
Yeah,
there's a sequence of numbers. To get the next term, we should add 2. We should add 2, right? If we assume that this number is n, so next number should be n plus 2. Next number should be n plus 4. Next number should be n plus 6. That is the power of algebra. Okay, now I'm using a variable to denote the unknown here, and we can construct our equation. That equation shows the relationship between the variables, how they are connected to each other. So say it says that 2 consecutive odd numbers, so we are talking about these 2 numbers. They are consecutive, right? One followed by another one. So here, product, that is n times n plus 2, that's equal to 195. Or bring it to standard form, n squared plus 2n minus 195, that's equal to 0. Let's see here, what we have here, quadratic equation. Now, nothing is mentioned here. You can use any method that you like to solve this. For example, me, what method I will use? I will use completing the square method. That is faster than even using the formula. Because here I have 2n, I can write it as n plus 1. N plus 1 squared. So if you expand this, I have n squared plus 2n plus 1. So plus 1, so minus 1, right? Plus 1 minus is equal to 0. Minus 1 minus 196, it is 196. Take to the right hand side. Here we have 196, which is equal to 14 squared. Then this n plus 1 equals plus minus 14 squared. That's just equal to 14. So here we have n equals, if you take the positive, -1 plus 14, it is 13, or n equals -1 minus 14 minus 15, right? And these are the solutions of the quadratic equation. But here it says that positive, right? So these numbers must be positive. So this answer is not a positive number. So this number is rejected. So we have to find the two numbers, the numbers. So then dots, dots, dots. If n equals 13, that is a first number. Second number should be 15. So those two numbers are 13 and 15. Okay? That is one example for problems that involves quadratic equation. Let's see another problem. Okay, that's our last problem. Okay, then I'll finish the class. Here we have just additional information to understand the problem. Here the certificate of entitlement of COE is a quota license received from a successful winning bid in an open with uniform price auction which grants, okay. It is something like this about certificate of entitlement. I mean, to understand this problem, we should understand what it means. Anyway, another example, that is the last example for today, okay? Just be patient, let's solve this together, and I will finish the class for today. It says that the manager of reliable car rental is a kind of company, maybe a private company, whatever it is, paid a total of $1.12 million for a number of certificates of entitlement. So we are seeing the a number. Actually, when you're solving the problem, you have to just scan the problem, read it quickly. You don't have to understand. Okay, what is it about? Just to get the general picture about the problem. Then when you're reading for the second time, then we have to read a bit slowly and read sentence by sentence and try to understand every sentence. And if possible, while you're reading the problem, we have to use a variable to denote the unknown, then form your equation, and after that, we solve the equation. So anyway, here paid a total of $1.12 million for a number of certificates of entitlement, that's COEs, at the onset of the Asian economic crisis in 1997. Okay, got it. 1 year later, he found that the successful bidding price of COE has gone down by $11,000 each, and that he could get 12 more COEs by paying an extra $40,000 for them, compared to the previous year. Find the number of COEs that we are talking about here, right? That thing, number of COEs the manager purchased in 1997, and the price of each COE then. Okay. All right. So now what is going on here? As simply to understand this problem, and we have a company, okay? They are importing cars to Singapore from overseas, whatever it is, from Malaysia, anyway. And okay, they import cars into Singapore. Now, to be able to use these cars in Singapore, they need to get certificate for the car. That means it's some kind of, let's say, registration cards, okay? Because maybe in different countries it's maybe called differently. In Cambodia, we call this registration card. In Singapore, maybe certificate of entitlement. In different countries, different, I don't know. But whatever it is a kind of license that allows you to use this car, I mean the cars in Singapore, okay? So how many did you buy here? A number of certificates. So that is, let's say this N. The first one is, that is N. Here, this thing is N. And for each, how much did you pay? For each, let's say you paid X $1,000, okay, in 1,000, because it's millions, that's why you better write in thousands here, okay. So for you bought N license, and for each you paid X $1,000, and in total is $1.12 million. So what will be our equation here? Then here we have N times that X, right? Let me just omit X, and here we have 1.12 million means it is 1 6 zeros. That's equal to 1 1 2 4 zeros. 1 2 3 4. So if I just write this in thousands, so that means that here we have how many thousands? We have 1,120. So here we have 1,120 because our x is in thousands here. All right, that's the first part of the question. The second part says 1 year later. Okay, he found that the successful bidding price of COE has gone down by 11,000 each. So this price, right, that's the individual price, because of that due to some reasons, it has gone down by 11,000. So actually don't forget that we are writing everything in thousands. 11,000 means 11 the thousands, right? That is x minus 11, okay, each. And that he could get 12 more COEs. In the previous year, he got N. Now, because the price went down, right, now he can get a bit more. By how many? It is 12 more. So here we have N plus 12, right? And by paying an extra 40,000, but here just he needs to pay $40,000 more. In the previous year, we paid in total this much, 11,020, but now we need to pay 40,000 more. That is 40,000, right? That is the question. Now we have modeled this problem or converted this problem into mathematical problem, okay? The next thing is we have to solve this problem. All right? How can I solve this? Amira, did you understand the problem and how we form the equation? Is it clear for you?
Yeah.
Okay. I mean, if it is too easy, just let me know. I'll go a bit faster. I'm just reading one by one so that we can understand. Anyway, so how do you solve this? It is possible because here we have two equations, two variables. So we can solve this. In math, if the number of unknowns is equal to the number of equations, it's always possible to solve the equation. So here, if you remove, actually simplify this thing, n times x. Here we have n x, n times negative 11, negative 11 x, 12 times x plus 12x, 12 times negative 1 minus 10 times 12, 120, and plus 112, it is 132. On the right hand side, 14,160. Okay, actually, I think I don't have to write like this. Let me just write as 1120 plus 40, right? From this equation, n times x equals 1,120. So these two things, they cancel out each other, right? So now let me try to express everything in terms of x. So here we have minus 11x plus 12x. That is, what is missing here? N times 11. Oh, this should be 11n, right? Because n times x and x, n times negative 11, negative 11n. And here we have 12x and negative 132. Okay, so let's write everything in terms of x. Okay, here we have minus 11n, all right, not n, times, instead of n, what is n from here? N equals 1120 over x. So here we have 1120 over x. Plus, here we have 12x. Now take this to the right hand side, minus 172. That's equal to 0. Okay, let's multiply both sides by x and hoping that x is not equal to 0. So here we have 12x squared, right, because of this, and they cancel each other. Here we have minus 172x, right, and here we have minus, all right, 11 times 11 times 1120. That's equal to 12320 is equal to 0. Okay, big numbers, no problems. We have calculator. So from here, delta equals 172 squared minus 4 times 12 times minus 123, 20. That's equal to 172 squared plus 48 times 1 to 3 and 2 0. That's equal to something, and that is 620,944. And square roots of the answer, that's equal to 788. That's equal to 788 squared. Now we can get the answer here. So x sub 1 equals 172 plus 788 over 2a. That is 2 times 12, which is equal to 172 plus 788, right? And is divided by 24. That's equal to 40. So the second answer, if you put here minus, it will be negative. So we do not use negative number to count the number of something or cars. That is rejected. So that is x. So from here we can get n. Then n will be 112. 1120 is divided by 40. That's equal to 28. So that's the first answer, that x, that is n, the number of COEs. Amira, that much is enough for today. Okay, you have a look and try to solve some questions until Sunday. All right. So we will meet again on Sunday. Now I will send you your assignment. Have a look and try to solve questions. Okay.
Okay.
Thank you very much, and see you on Sunday. Bye bye.
Yeah. Thank you. Bye.
Yeah, you're welcome.